Welcome to qnawire.
Okay, we have the following molecule, and I'm going to go ahead and actually put lone pairs on some of these atoms that I know to have lone pairs that were shown in the picture. And I've gone ahead and recreated this molecule and also labeled the carbons instead of or labeled the atoms outwardly instead of just underlining them and adding a subscript, because I didn't actually put the letters in the structure itself. Hopefully you can see the correspondence. This is C2, this is the nitrogen, this is C1, and this is the oxygen. And the question is, which of these atoms are sp2 hybridized? Okay, well, what I would say is that there's a trick to this, okay? And that trick is you simply count the number of lone pairs and the number of atoms, and I should say not bonds. We're not counting bonds, we're just counting the number of atoms that an atom is connected to, right? So something else that may help here is I'll draw in the implied hydrogens. That is, we know there's a hydrogen here, even though I haven't drawn it. Okay. And then let's step through this process and see what I mean. Let me put this label back. Okay. So how many lone pairs does this carbon have? None. It has no lone pairs, right? I would have drawn them on, or they'd be shown in that picture if it had lone pairs. We also know that carbon with lone pairs has to have a charge. This is neutral. So, okay, no lone pairs. So 0. Okay. How many atoms is it connected to? Not bonds, atoms. Well, I see 1 hydrogen, 2 carbon, 3 another carbon. Okay, 3. And then the rule is you sum these up. Okay, and then if the total is 4, it's sp3. If the total is 3, it's sp2. If the total is 2, it's sp. And this kind of makes sense, because remember that sp3 is s with 3 p orbitals, and sp2 is s with 2 p orbitals, and sp is s with 1 p orbital, right? So number of orbitals is 4, number of orbitals is 3, number of orbitals is 2, right? 2, 3, 4. Okay. Yeah, so that's a shortcut, or a trick, if you will. Okay, so this is sp2, right? We just determined that. It's connected, it has no lone pairs, connected to 3 atoms. 3 corresponds to sp2. It's sp2. Okay. Let's look at this nitrogen. Let's do the same thing. How many lone pairs? I see 1 lone pair. How many atoms is it connected to? Okay, carbon, and then 2 connections to hydrogen, right? If we wanted to be more formal about this, we would draw this. Hydrogen, hydrogen, like so. Okay, and then we might more clearly see that this nitrogen is connected to 3 atoms. Okay, and if we sum these numbers together, we get 4. Okay, meaning that this nitrogen is sp3 hybridized, not sp2. Okay, let's move on to carbon 1. I see it's connected to 1, 2, 3 atoms. It's got no lone pairs. Well, that's the same as our other one. 0 lone pairs, 3 atoms, sp3. Okay, so this carbon is also, sp2. This carbon is also sp2. Okay. Finally, this oxygen. What do we got? Let me make some space over here on our table, our chart. Okay, how many lone pairs is oxygen connected to? 1, 2. How many atoms? Hydrogen and carbon. 1, 2. Sum those together, what do we get? 4. 4 corresponds to sp3, so this oxygen is sp3 hybridized, not sp2. So our only carbons that are sp2 hybridized are carbon 1 and carbon 2. Is that an answer? Yes, it is. It's the 4th answer.